course. My name is Leonardo Silva, and today we are going to the third class of our course. So what we are going to cover on this class is basically operators. So we are going to introduce what are operators in RxJava and explain the different categories that we have, like the different types of operators that we have in RxJava2. And also we are going to cover the first some operators from the first type of operator, that's the creating operators. So let's start. So just to recap about event emitters. So what are event emitters? So in RxJava2 we have four different types of emitters, event emitters. The first one is observable. So this like an emitter that can emit one, zero, or many events or an error. So just to recap, uh, emitting an error event doesn't mean throwing an exception outside of RxJava world. Everything is an event. It's just a different type of event that we handle in a different way, not like a catch, for example. Um, then we have Flowable. That's an emitter that can do the same as Observable, but with support for back pressure, and that's something that we are going to cover on the future in this course. And we have also the single, that's a emitter that can emit one event or an error. And we have the maybe that can emit one or zero event or an error. So this just to recap. Then let's go for operators. So what exactly are operators? So operators tells the emitter how to manipulate the events. So let's imagine we have this tree. So let's go back. We have the single, and then inside single we have methods. So that's why in RxJava, operators are just methods inside the emitter class or object. Why do I say class or object? Because if you remember, for example, you have the method single.just. Just is a method in RxJava, is a method in the class, so static class. So it's a method that belongs to the class. But we also have, like, if you have an object of single or any of this, we have the method called map. That's also an operator, but this is bound. This is the operator belongs to the object itself, not to the class. So that's why you have operators inside the class, but also inside the object. So yeah, so just as I said, it's just methods that helps the emitter how to manipulate. By manipulate, I mean transforming, filtering, many other things that we're going to see in the categories. So RxJava has a lot of kind of operators for different things. So that's why they have this predefined categories, they say. So they have the first category, that's the creating observables. So it's basically the operators that exist for creating they say observables in a general term, but when I say, every time I say observable, understand that an emitter. So observable is an object that can be observable. So is an object that emits event, so someone can observe or can consume these events. Let's think like this. But the general term for reactive, like the definition of reactive X, not only to RxJava, is observable. But in RxJava we have, since RxJava is an implementation of reactive X, we have different type of emitters that all of them are kind of observables because someone can subscribe to it. So we have the creating observables that can create emitters or observables. I'm just don't want to use just to for you to understand. I try to use emitter every time because observable, as we are doing in RxJava, this can be confusing because we have the emitter that's called observable. So when I say creating observable, I mean creating emitters or whatever. I think you got it. And we have transforming observables that are basically the operators or the methods that helps our emitters to transform the data coming from some other emitter. We have the filtering observable. I think that's self-explanatory. So it's just to filter events that we want to pass to the next handler or observable or not. We have the combining observables. We're going to see this, but it's basically if you have like two observables, each one emitting two different type of events, and you want to, for example, group them in one place. You want to do a reduce, for example. That's something that you probably heard about, or you use in string, for example, or group by, you can do the combining observables. You have the error handling. So error handling provides some operators for you to, if you have like an event that is an error, you can do a recover, for example. You can do a retry. You can do many things with error handling operators. There is also the observable utility. There are the conditional and Boolean and mathematical and aggregate. So we are going to focus first in the creating observables, transform, and then next class we probably go for transforming and filtering and combining, and then we see a bit of error handling, and I will see the what exactly will be useful for us from all these operators. Uh, so okay, so let's go then for the operators that interest to us. So the first one we are going to see, so we have, I listed here not all of them, but I listed the most important from my point of view in RxJava. So that are the create, the differ, empty, from, interval, and timer. We already used some of them, but let's create now some of them. So let's go create here a package called operators creating. Then I'm going to create a class called create. And then what I'm going to do here, I will do, so all these operators here, create, defer, empty, from, interval, timer, all of them, only single does not have empty. Yeah. Let me just recap. I think single, yeah, exactly. So all of these operators, but have exist in all these four emitters that are single, observable, flowable, and maybe. Only single does not have empty because, as I said, a single cannot emit zero event. A single must emit one event or an error. So that's why it does not have an empty one. So let's go for the most generic one, that's observable. Then we have the first method, that's create. So create is the most flexible operator that we have because you can do whatever you want. You basically receive this guy that will is a lambda. It's in fact an implementation of observable on subscribe, and then it's going to receive an emitter. So just for you to understand, if we go to this class, it's basically an interface that has a method called subscribe, and that's going to receive an emitter. So here we are using lambda, then we receive the emitter, and then in emitter we can do whatever we want. We can say, okay, emitter just on next, and you can emit a value. And then you say, okay, now on next again, and do 12, 20, and then on complete, and say, okay, I'm done. I already emitted all the events. OBS, and then I'm going to see OBS subscribe and create n. And I'm going to print this. So if I run now, right? Perfect. So that's why I say this create operator is really flexible because you can do whatever you want. You can do a whole logic here with try catch, for example. You can come here and say, okay, I want to do a try catch here. Oops, whatever here. Oops, here, try, then catch, and then exception. And if there is an exception, I'm going to say emitter dot on error and emit this error. Then I run and everything fine. Then you can say, okay, but what if here there is an exception not handled exception? So runtime exception. Then we're going to say blah. There's an error, and then I'm going to pass another. Let's do nothing here. Show this. So if I do this, what's going to happen then? You see that it's an error that RxJava is basically saying, okay, there was an exception there. So RxJava handles this for you. So you don't need to specifically create the try catch here. but in fact, it's a good practice for you to do that, because when someone see the code, it's clear that there is an error that can come from this method. So it's a good practice. But if you don't, RxJava already understands this error wrap, and you see that here it's generating for you not an exception, but generating for you an error, an event with an error. But then you see the exception was not handled due to the missing on error handler. So the problem is not the error itself. The problem is that you didn't put the callback here to handle the error. So if I do here, so for example, ex.message, I run this now, you see that's just printing out the message. So RxJava already handles this for us. So this part of the operator, the operator itself handles the error for us, right? This is the create operator. So if you go to the second one, the fur is also, let me create a new class here. Oh, not this. So let's do now with single, the fur. So what it returned for, it received for us is this. So what I need to do here is that I need to return another observable. Then you say, what? It's just a bit strange, but I will explain a real use case for this. And then if I do single dot subscribe, testing dot out print then run this. Oh, not this. You see that's running. Okay, but why I just don't put this single just directly, right? This would do the same. If I do this, this is going to work as well. But I'm going to explain one scenario that I already passed many times. So let's imagine that you want to use RxJava, right? But you are using like Hibernate. So let's imagine that you have a class, a method here called get, like returns an integer, get ID. And this get ID is basically going to the database and doing something, right? So this is going to return like a single of integer instead. Then it's going to return a single, an ID for you. And then you come and say, okay, single dot just, and then you do here like a db dot fetch ID, right? That's all that way. So that's what exactly what it's going to do. When this method calls get ID, this is going to do single dot just, but then this is going to evaluate this method and goes to the database directly and fetch everything, right? This maybe looks fine now, but let's imagine that you have like here, you have like a single that has like a map, I don't know, like I have 10, but then you start to do, okay, flat map, I want to get the response from this guy, pass to the next one, and then you start to chain single to another single. So here you can say, for example, n, but you want to return here get ID, right? Then what's going to do? This is basically this. So you have like a 10, a number 10, and then you want to get the result of this event that will be 10 and flat map. So basically you're combining, you're transforming this data to get the ID, for example. Let's imagine that the ID you have the, I don't know, old ID, let's call this old ID. Next. So you do like this, right? Looks fine, but what's going to happen? Remember that the emitters, in this case they are cold. So this means that until someone come to it and say subscribe, this is not going to execute. This should not execute. This is just code. But in fact, what's going to happen is that when you do this, plus this and call this method is going to generate the single. But when you do just, this is going to be evaluated already. So this method will be executed before someone subscribes to it. Maybe that's something that you don't want. Because imagine that you have a long flow, and then you have like a filter, for example. This will be a good one. So you have n here. Oops. Then filter, you're going to say, okay, I just want to receive the event if the number is higher than 10. And then you do a flat map, for example. So when we are creating the chain and everything, this is going to create the single for you. So it's come to here, okay, create the operator, filter here, set the operator. Is not going to filter anything because it's, as I said, it's a cold observable. Then we go for the flat map and create the other single. That's going to be this guy. So it's going to create this get ID that's going to pass this one and blah, 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 and fine. But then, as I said, there's no event being generated. No one subscribed to it. But you already fetched this in the database. So it's wrong. It's just wrong. So what should happen is that when you do some operation like this, like you want to just transform a normal information that needs to be executed through database, through API call, anything that you don't want to do right away until someone subscribes to it, you do a defer. So you basically come here and say, okay, single dot defer. And then here you do a single dot just. Because what's going to happen here is that when this method calls, this is going to call single dot defer. And then we'll pass this guy without executing this. This function will only be executed when someone subscribes to it. So when someone say, okay, integer single dot subscribe, and then only then this is going to be evaluated. And that's exactly what you want. Int ln. Let's call this. What's going to be here? Single. Oh yeah, filter because it's transforming into a maybe. Okay, so that's the idea of the defer. So let's go for the next one. That's empty. So let's create a new class here. So empty is pretty simple. Empty. So let's do a maybe dot empty. Then I do a subscribe. I do here n, that will be a value, for example. System out dot println, right? So we are going to subscribe to it. Now if I run this, we see nothing because it's empty, right? So, but if I see here, I have the onSuccess, but I also have the Flowable and also the onComplete. So let's use all of them. So here I'm going to receive the error. I say print struct trace, and onComplete, I just say completed. So empty basically create like a emitter that emits nothing, just complete. It also works for observable and also for flowable, because as I said, all of them generate empty events. Only single does not generate anything, generate zero, generate one event or an error. Now let's go for the from. So from, the idea of from operator is basically create this guy does not have, a single does not have, because from the idea of the from method is to create events based on like a collection, like a list, for example. Here what we have, and we have like from callable, from future, that's not what we want. So let's go for observable from, and then yes, and this is some change that happened from RxJava1 to RxJava2. Here I copied the name of the operators that we have in Reactive X. So we have the from. In RxJava1 you have from operator. In RxJava2 you have only from array, from iterable, from publisher. But works in the same way. So for example, in from array, it's the same. In RxJava1 you just do this, for example. This works, or like an array list, for example, where both works. But here you need to, in RxJava2, you need to explicitly say if you want to do this by array or iterable. So if I do that here, and if I subscribe to it, system.out println, if I run this now, they should create allow for events for me. That's exactly what I wanted. And then we go for interval. Interval we already saw in the last class, but I will create here again. Interval. So interval, what happens is that let's create also interval. If you see that there's no interval in single, because single only emits one event, and interval is intended to emit a lot of events. So if you can, maybe should not have as well. Yeah. So if you go to observable or interval, you see that's going to generate one event depending on the configuration that I do. So I'm going to say like 1, and here I think it's chrono unit dot seconds. Oh, let me recap, because I used this previously. Time unit, yeah. Time unit seconds. So 1 second. Then I'm going to subscribe to it. Then it's going to print system.out println, and let's run this. And then you see that I see nothing. And you ask me why it should be creating one message per each second. The point is that the interval operator, it does some magic behind the scene, that it uses a different thread for it. So for example, I will prove that to you, printing out started, and here I'm going to print the thread.current thread.getName. And here what I'm going to do is that I have this, and here I'm going to print new event in the thread, and here I'm going to say finished. Now I'm going just thread.sleep 10 seconds. If I run now, you see that this is just run in the main thread, and this is running in a different thread. That's the Rx computation thread pool. So every time you create an interval, this starts a new thread under the hood and start to run this code in the new thread. Only this execution in the new thread. In that case, it's it basically creates a function for us that's going to print, that's going to generate a new. Let's print what it's generating here. It's going to generate one event once each second. So it's basically generating the index of the events. So event 0, event 1, blah, 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 blah. So that's a really interesting operator that we can use in real life. Then we have also the timer. So let's see that. Timer. So if this timer is the same, compared in the sense that you cannot use this with maybe. Oh no, sorry, timer you can do that. Timer, because timer only executes once. So what you can do, you say like delay of 1. So timer is something that you can use in all the emitters. So you do the same, once delay and time unit second. You do subscribe out println. That's it. So it works exactly the same way. I mean, it just prints one. It just emits one event, but in the same way that I mean is that um, it runs in a different thread as well, just like it works with interval. But instead of emitting a lot of events in the given time, so once a second, it generates only one event. So it basically delays the emission of that event. So if you do here as well, see that and just delays the event in 1 second, but that's the same. Okay, so let's go back. Show me the code. That's exactly what I did. So okay, guys, that was the class for today. That's what I wanted to talk about. So now, next class, what you're going to see is the transforming operators, at least the most important ones inside this transforming group. And also, I'm going to give you an exercise to do by yourself using the creating plus transforming operators. So this exercise, I think it will be good for you to do, and then you can make your knowledge about the operators and the basic creating operators for creating and transforming operators more solid. So I hope you like it. See you next class. Bye bye.